Okay, we're talking about spheres today. Do you guys know what a sphere is? No. It's like a ball. It's 3 dimensions. A circle is flat. A sphere is 3 dimensional. Yeah. So the surface area for a sphere turns out 4 pi r squared. So remember pi r squared was like the area of a flat circle. So if you just do that times 4, that gives you the surface area for an entire sphere.
Why 4?
So a sphere has a radius, I don't know. I have no idea why that works actually. A sphere has a radius just like a circle does. So just another, basic little thing. Okay, the other thing we're talking about today is polyhedron. And we have talked about prisms, right? Prisms are like where you have one shape and then it's like stretched into the 3rd dimension. Like that, that's a rectangular prism, triangular prisms, and all those kinds of prisms. Today we're talking about shapes that like are the same on every side. That's called a polyhedron. Polyhedra is the plural. It's really hard for me to draw these, so for the most part, we're just going to look at page 356. Go ahead and turn to page 356 at the end. You guys see the bottom of page 356? Those are polyhedra. So you see how they're different than prisms? Okay, they're not just a stretched like rectangle or anything. It's like a bunch of triangles on every side. Okay, so for example, you guys know a hexagon. What's a hexagon?
Hexahedron?
It's a 6-sided polygon. Okay, a polygon is just a flat, this is from the past, hexagon. A hexahedron is a 6-sided 3-dimensional shape.
So like a cube?
So like a cube, exactly. Now, a cube happens to also be a prism, but that's the only one that's like the same on both. Prisms are normally different looking than polyhedra. If you look at the pictures, you can kind of tell. The octahedron, what did octa mean? 8 sides. So if you look at their octahedron, it's 2 pyramids like stacked on top of each other. I don't know, can I draw it right?
No.
That's not right, is it? Fail.
What is that?
Hey,
What are you trying to draw?
should it be over here?
No. Wait, I think I can do it, genuinely.
Wait, what are you?
Trying to draw the octahedron. I think you just can't see it right there. Looks like that.
Close enough.
Sure.
I'm not sure about the bottom.
Pretty sure you have to make like that leftmost angle
I gotta look at
or
the book, see
right
what it says.
angle so that it.
Yeah, like you have to like shorten the length a lot.
Yeah.
Yeah.
Like that.
No,
Uh,
this is not going well.
It doesn't matter, I don't need to draw it.
Just draw a triangle and then like a little side over there.
Yeah, I know.
But you don't know because you're trying to.
It's
I saw
it's
it.
just a rectangle.
It's just not working now. Here, let's see if I can cheat. Let's see if this works.
Bottom vertex has to be like parallel.
You have to
with
make
the
the other side
top,
a little
right?
skinny.
Here, see if this works.
Oh.
Uh-oh.
I know tricks.
Holy crap. He's a legend. Let's go.
Reaching intelligence levels that shouldn't be possible.
It doesn't work. Oh my goodness.
I'll take that.
It's
Why does it not look right upside down?
Because you're not drawing.
Because no, you have to like
Because
flip
you have
it.
to angle. You have to.
Okay, well, let's try that.
Just like
No.
flip. Yeah.
Yeah.
Maybe.
No. You have to make one. You have to make the left side skinny.
Yeah, like super
But you
skinny.
make the
Here,
left
can I
side
draw
fat.
it on the whiteboard?
No. That's enough of that. Okay, I can't play too much. Alright, anyway, it looks like a pyramid on top and a pyramid on the bottom. So it makes 8 sides. Dodecahedron. How many sides do you think a dodeca has?
12.
12. Okay. And notice on the dodecahedron, each side is a pentagon.
Yeah.
Icosahedron,
20.
20. Some of you have it written in your book, don't you?
No.
Okay, which is fine. I probably told them to do that a long time ago, but Icosa has 20 sides, dodeca is 12. Now, here's the thing though. We got a hexagon and a hexahedron. Most of the time it's like that, like it has the same prefix, except for on the 4-sided thing. A 4-sided polygon is called a quadrilateral, right?
Yeah.
Like that's a quadrilateral. A
Yes.
4-sided,
Tetra, right?
yeah, a 4-sided polyhedron is called a tetrahedron. So that one's kind of weird. That one I could actually draw because it's just a little pyramid. Let's go see if you guys are gonna challenge me on that.
What?
Okay, let's jump in on page 357.
I think you
then.
should try and draw it.
I can do it.
Okay. I don't believe you because you tried to draw an octahedron.
That one was much harder.
No, it's
Yeah,
not
3
though.
triangles.
It's easier.
I'll give them the benefit of that one.
There, the end.
No, you gotta draw like the back line.
No, it doesn't have a back line. It's coming out this way.
It's,
Oh.
No, it's
Oh.
a triangular.
This, you
base.
mean?
Yeah.
Yeah.
Goody.
I'm telling you, it's easy to draw.
Beautiful. That is art at its finest.
I'm just jealous.
No,
You
it's
need to
not.
make-
It's easy.
It's
You
like
need-
a
It's sad.
Picasso, you know.
For the octahedron, you need
Okay.
to make it that skinny.
Number 1, so we got one formula that we learned today, 4 times pi r squared. That's for the surface area of a sphere. So on number 1, how are we going to find its surface area? Radius is 4. Let's probably bring this over here.
So 16 times pi times 4.
Yeah, so basically it's 4 times pi times 4 squared. 4 times 4 is 16, times 4 is 64 times pi. Let's go ahead today and turn it into the decimal answer. Let's round to the 10th place again, like we did yesterday.
201.1.
Okay, so again, if you're using 3.14 for pi or you're using the pi button for pi, that's going to change your answer slightly. The pi button is a little more accurate. And this is just units, right? They don't tell us anything. So 201.1 units squared.
I drew an octahedron and it looks better than yours.
Good job.
I can't see it.
Just, it looks perfect, Austin. That's all you have to know.
Okay, number 3. How are we going to do that one?
Square root of 5 times 4, but it would be the.
Well, it's square root of 5 squared, right?
Yeah. So
Square-
wait, that would take it out of the square root, right?
Yes.
Yeah. So would it be 5 squared, or would it be just 5?
It'd just be 5.
Yeah.
Square root of 5 times square root of 5 is square root of 25, which is normal 5. So yeah, the square and the square root always cancel out. So it's 5 times 4 is 20. So it's 20 times pi, which is what?
62.8.
I think you better go over here. Alright. Numero 5. Numero. Probably the better pronunciation. okay, it says the surface area of a sphere is 320 pi square yards. What is the length of the radius? So they're giving us the area. They want us to work backwards to find the radius. So how could I set this problem up?
So 4 pi r squared equals 320 pi.
Exactly. So you set the formula up to equal the area. And how do I solve this?
You have to divide by pi and then do
Yeah,
the
4 pi.
square root.
What's going to happen when I divide by pi?
It's gonna turn into this.
No.
Wait.
What's pi divided by
It's
pi?
gonna cancel out.
It'll cancel out basically. Divide both sides by pi, it just gets rid of it. Now what?
Square root of 320.
Nope.
320 divided by 4.
Divide by 4.
Well, aren't you
Get it right, Nick. Jeez, it's 80.
I said that.
Oh, you did. I'm sorry, Alex.
Okay.
That's
But it's the
okay.
square root of 80.
Okay, it's the square root of 80.
Which is I don't know what.
Alright,
Well, I'm showing.
now if we did this the hard way, does the square root of 80 simplify?
No, it does not. Wait.
Six.
It's 4 square root of 5 or 8.9.
Okay, it's 4 square root of 5. Did this give us... this is in yards, I guess.
Nick, how does it feel to be bad at math?
Feels wonderful.
It's either 4 square root of 5 or 8.9.
Do you care which one it's in?
No, today we're going to stick mostly with the decimals. The book actually wrote both, if you look at it in the back. Alright, 7. This one's actually pretty hard.
12 is the first.
Yeah, a dodecahedron has 12 sides, 12 faces is what they call it. To do this problem, you need to look at the bottom of page 356.
What does it mean by edges? Like
What do you guys think edges means?
the sides of
Yeah.
like the line?
Yeah, the black lines, like the edge of a table. So,
Can you do 5 times 12?
no, that would be nice, wouldn't it? Because the edges, you know why you can't do 5 times 12? Because, like, if you look at the front pentagon,
Oh, is it
those
because
sides
the-
are shared on a bunch of other pentagons.
Yeah. Like one pentagon makes up like a side of like.
Like each pentagon has 5 sides, but some of those sides are double up on other pentagons, so you can't just do 5, 5, 5, 5, 5. It's a little more complicated than that.
Should I be counting all out?
Yeah. Why don't you get everybody to try to count? This is the hardest one, by the way. Number 7 is the number of edges.
I'm getting lost at 3.
So I would start at the top with those 5, then I would count down. The line's going down from there, and that should be 5 coming down, and then I'd count down from there.
48.
You're very close. It's not 28 though.
Is it 26?
No, getting colder.
Is it
It's 30.
21?
It is 30, yeah. Did you actually count them?
No, but like no. Well, okay.
What'd
My
you do?
thought process was like
60
like
divided by
60.
2.
Yeah.
Okay. You just felt it.
I was just like, yeah.
Alright,
maybe
that's
it's-
fine. That's fine. There's 30 edges. I thought maybe there's a trick to finding the edges, but if there is, I haven't figured it out yet, so. Okay, what do you guys think vertices means?
The
vertex.
right
The
here.
little triangle points.
The corners, yeah, corners.
Oh.
Wait,
This-
you do 12
That's
times
even
60
worse.
there though?
No,
No.
definitely not. They're a little bit easier to count. There's not quite as many.
There's not a trick for it. You can't like.
Wait, what were we
multiply that
supposed to
out.
count the first time? That's what I was counting. I was counting this.
Okay, this isn't, an edge is like this.
Oh, so like the outside?
The vertices is the corner,
Oh.
vertex, like the corner of the shape. And there's a different number of vertices. It's a little bit easier to count.
I counted 27.
That's too many.
I got 30.
25.
No.
Oh,
You guys are getting too many somehow.
Is it 21?
16.
Wait, no.
Is it 12?
Okay,
Wait, I can tell you what it is, hold on. Just split second, somebody count 10. I should have been cheating earlier, I don't know what I
are
was
your
saying.
answers written in your book? Oh, in the back?
They're back in the book. I can-
Okay, if you look at the top of the shape, there's 5 up there, right?
Yes.
Yeah.
And then if you climb down to like the middle, it's kind of hard to see, but like if you look at that one on the front, there's 3 on the bottom of the front that have not been counted yet.
It's 108.
No, you're looking wrong something.
Oh, I don't know.
And then if you like keep
It's
counting,
20.
if you keep counting around the sides, there's like 3, 4, 5, 6, 7, 8, 9. Basically, there's 9 in the middle. Or 10 actually, I missed one. There's 10 in the middle.
Should I try
And then
to-
there's 5 on the bottom. There's 5 corners on the top, 5 corners on the bottom, and 10 around the outside.
So
So
20.
there are 20.
I said that.
Yeah, and I looked up in the back. You get it. Number 9. Without looking it up in the back.
I hate the charts.
This 9 is actually easier.
Is it
No, it's
8?
just
7 was the hard one. Octahedron.
8.
8.
8 faces.
good for you.
Thank you.
Okay, number of edges.
12.
Okay,
What?
number of edges on the octahedron. Yeah, if you look at those pyramids, basically there's 4 lines coming up, and there's 4 lines going down from the middle.
And there's
That's
4
not
lines around.
And then there's 4 lines around the square in the middle. So 4, 4, 4 makes 12.
That's not on time, is it?
No.
No,
That's when our class would usually.
that's the chapel schedule.
Yeah.
Yeah, we would just be starting class right now. Okay, and how many vertices are there?
Oh, 6.
Yeah, 1 on top, 1 on bottom, 4 in the middle. So that one was definitely easier, right?
Yeah.
Okay, the other hard one is the icosahedron.
Oh, that's gonna be so dumb. We
We
skip
can just
that
do
one.
it. It's cool.
No, you guys can try. If you want me to help you later, I can, but number 10 is the hard one. And it's not in the back, Jordan.
I know. It's unfortunate.
Okay, number 11. All right, an octahedron. Okay, it says give the surface area of each regular polyhedra. What do they mean by regular?
Like it's equal?
All the sides are the same. Okay, number 11 says an octahedron. What does octa mean?
8.
8-sided. With one face of area 10 square inches.
80.
Right, so if one side is 10 and there's 8 sides, then you're just gonna have 80 square inches. See how easy that was?
I'm so smart.
Easy peasy. Now, unfortunately, the rest of them are a little bit harder, but they're not that bad.
I don't think I have enough mental brain power to do number 15.
Do you guys know how Nick got 80 on that one?
He took 10 times 8 because they're
Yeah.
like the base area was 10, so and there's 8 faces. And so
Right.
he did
So it told us the area of one side is 10, and an octahedron has 8 sides, so we just did 10 times 8. Okay, number 13, icosahedron. What's an icosa?
20.
The 20. What shape makes up the faces of an icosahedron?
Triangle.
Triangles. Okay, the info that it gives us on 13 is that each edge is 6 centimeters long.
Can't you do 6 times how much?
So 6.
So
times
what
30.
information am I missing that I really need here?
So if you could do 6 times 30 times 20, right?
No.
Okay, how do we find the area of this triangle? What am I missing to find the area of this triangle?
the all the
surface
other
area.
triangles.
No, we're just doing the one triangle on one side of it, one side of the
Space times height.
space times height, so I'm missing the
So the area
The
of
height.
height.
Oh,
So how do I find the height?
It's
Pythagorean theorem.
Pythagorean theorem. What's this right here?
3.
3.
So it's 3 squared plus height squared equals 6 squared. Yeah.
I wanna know who invented math.
It's more like discovering, God maybe did.
27. Which, wait,
You gotta blame God,
all
Chase.
these square
Yeah.
root.
He's a jerk.
He's probably laughing while I made it, like, these stupid kids are gonna try and figure this out.
I don't think so.
5.19.
Okay.
So
Actually, I'm gonna leave this one in the square root form. You guys know how square root of 27 simplifies?
You know?
9 times 3, right?
3.
Yeah, 3 square root of 3. Okay, that's not our answer. That is the height. So how do we find the area of a triangle?
Half times space
6
times height.
times 3.
1/2 times 6, which is what?
A lot.
1/2 times
Oh.
base times height. 1/2 times 6, 1/2 of 6 is 3. 3 times 3 is,
It's 15.6.
no, we're not doing decimals on this one. 1/2 times 6 is 3, 3 times 3 is 9.
So it's 9 squared root of 3.
Okay, that's the area of this triangle.
So you gotta do that times the.
Yeah,
sides.
what were we doing in the cosahedron,
I
right?
don't know how many
Yeah.
sides.
Yeah, because it's
Icosa was how many sides?
20.
20.
20
So we need,
Shut up.
we need,
It would be bad
So it's 311.8.
okay, again, we're not doing decimals on this one. 9 times 20 is 180, so it would be 180 times square root of 3.
You know what, Nick? I was trying to be helpful. You're just sitting over there criticizing me. I feel targeted. I feel like I don't know where this hatred is coming
Alright,
from.
stop being defiant and no one will hate you.
Oh my gosh.
I was not being defiant when she said that though. Like I wasn't being defiant. I wasn't. You weren't even there.
I wasn't, but I just like to think that you were.
Wonder if David's gonna watch this and miss out on all this drama.
I doubt it. He'll be glad.
Probably
it's
not
over.
watching, but okay.
But
Number 15, last one.
Did you get centimeters squared?
Yeah, it was centimeters on that one. A dodecahedron, what was the dodeca thing?
Dode was 12.
12. What were the sides of a dodecahedron were made up of what?
Pentagon.
Pentagons. How have we found areas of regular pentagons before?
base times height.
No.
I'm just kidding, I have no idea.
That's like a rectangle. Does this ring a bell for anybody?
Oh, apothum. Wait, 1/2 times apothum times perimeter.
Right. 1/2 apothum perimeter. That gives us the regular area. So it says the edges are 14 feet long. So that's a 14. And
Hold up.
Who was
that's anybody.
it?
And maybe somebody's checking the door, see if they're locked. The apothum is 11 feet long. Okay, so I got 1/2 times the apothum times, what's the perimeter gonna be? 14 what?
It would be 70.
14 times 5, 70. So 1/2 times 70 is 35, 350 plus 35 is 385. Is that the answer?
No.
No.
No, that is the area of one side. And how many sides do we have in the
12.
dodecahedron? 12. So we need 12 of those.
4,620.
And what kind of measurements are these? Feet? Alright, there you go. Everybody everybody in the other class got this one done, so let's try and get this done. You guys got about 17 minutes.
We're not as smart as the other class.
You can still do it.